All right, so here's I think where you've arrived. You're in a good spot. Check it out. If you got 110 degrees here, you saw, hold on, hold your horses. Psst, psst, psst. The 110 came from, you get 90 plus 20 is 110 degrees. I think you're all pretty convinced of that one. The next one, it looks like it does an extra loop-de-loop. There's a lot of things you had to kind of deduce, and you've done wonderfully. The angle 30 degrees inside here was something you had to deduce. It wasn't written. But it's important because this angle here was 360 around. You can see it doing that extra loop. 360 plus 30 degrees is the actual positive angle of this. So you put 390 in there, I hope. Doesn't it go around twice? Does it go around twice? Yeah. You mean another 360 on top of that? I'm going to have to get my calculator out like some of you did to add this up. 9 and... No, I'm going to add it up here. So you got 0, 15, 4, and 3. 750. Nice. Psst. All right. Hold. If you want to do the next angle, 105 minus that, so you did 75. And I think everything went fine after that. What then came up was the radian measure, and that's just a simple... If you have a degree and you want radians, you multiplied by pi over 180 so that the degrees canceled, and then you simplify as necessary. You should have gone to 11 pi over 18 and said, yippee, I'm done. The others are similar. I'm not going to go beyond that. This next one, though, coterminal. Cool. Okay. So 2 pi over 5. If you want to get a coterminal to that, if you don't know where 2 pi over 5 is, that is just fine. It's a fifth of the way to 2 pi all the way around. So think of, if you broke up this into fifths, you're going a fifth of the way, 2 pi over 5-ish. So what do you think? Is that a fifth of the way to 2 pi? If this is 90 is a fourth of the way, a fifth of the way would be a little bit smaller. So let's ballpark it. Let's say it's like that. To get a coterminal, you can add or subtract multiples of 2 pi. You go around again. Just like we did in that last one. If you go around again, you add 360. In radians, if you want to get a coterminal, you can add 2 pi to get a positive one. You could subtract 2 pi. You could get a coterminal that way. You don't have to do just 2 pi. You could do 2 pi's, like 4 pi, or 3 2 pi's. 6 pi, or 7 2 pi's, whatever you want. So Owen can add and subtract as many multiples of 2 pi as you like. If you just need an example, 2 pi is sufficient. Now fractions come into play, because I don't know about you, but adding 2 pi to this may not be in your wheelhouse at the moment. But if you make a common denominator, if you take this little fraction up here times 5 over 5, then you realize you can get a common denominator. So times 5 over 5, boom, boom, right? And then you can add these two together. So this becomes, let's go back to let's do red. I like red. That'd be 10 pi over 5 is the same thing as 2 pi. And so you'd get 12 pi over 5. So just get a common denominator with your 2 pi to whatever you're adding. And then you can get your results. Remember when you add like terms, you don't change the denominator, so it's over fifths still. One answer. The other one is subtracting 2 pi over 5, so we're going to subtract 10 pi over 5. And you're home free. Correcto mundo? That's it. That's the process. You just need a common denominator for your multiple of 2 pi that you're adding or subtracting, and all will go well. So negative 8 pi over 5. Those are examples. If you're just feeling really frisky and you want to impress the people around you, and you should, maybe you want to do 2 pi's and subtract 2 pi's or 3 2 pi's. That's fine. Go nuts. But as long as you're doing a multiple of 2 pi added to get a positive, or subtract by a multiple 2 pi to get a negative, you're home free. Done.